So here's the start of the process for making your own clear circuit boards. I use this awesome UV glue. It's from Matronics, and I use these microscope slides and some copper leaf I found on eBay. You actually specifically want the kind that's for PCB manufacture. So you can see on the back here it's a matte finish, and on the front it's a shiny finish. That seems to work the best. I tried really thin stuff, didn't really work out well. And one of the things there is they only sell in packs of 10, so I'm thinking about selling these online if there's anybody interested, since I bought a pack of 10 and I can't seem to find anywhere else to buy them. So the first part of this process is we flip this over, and you can see that it's nice and matte, and I have this nice little microscope slide here. I tried avoiding touching it at all, that way I don't get any of the oils from our hands on them. So I'm going to use some of the UV glue here and just put a couple drops, just very, very ginger with this. Okay, so once you have that laid out, then put the glass slide on top, and you'll see that there are bubbles that form here and there. So what I do is I just sit there and I kind of push them out, and you can actually squeeze the bubbles out fairly effectively. And you can also push these things to the far ends there, so it's kind of pushed out here. And you'll notice that as you push the bubbles out, the bubbles seldom try to suck themselves back in. You also kind of want to do it on a stable surface. It seems as though these Celestron microscope slides have a UV coating. So when I put them in the UV eraser here, it's actually an eraser, but I can use it as a glue cure, I have to leave it in extra long. Seems like the curing or the coating slows down the reaction but doesn't stop it altogether. So I simply place this in there, give it one last little tappy, and then I can turn it on. Let's go for 35 minutes is usually a good amount. You can even peek on it, make sure everything's cool. Yep. To come up just a little bit. Let's back down. Okay. So once you've designed your circuit board, you'll want to use pulsar paper, or like I use pulsar paper. You can use any number of toner transfer systems. I very much prefer pulsar paper. You can get it from DigiKey or just about anywhere else. And so I use a laser jet, and I put the pulsar paper in glossy side up. As you can see, it's really nice and glossy. And then I go and I hit print. So I'm printing now. And so the toner sits on top of the toner transfer paper, and it's like little plastic, and I can transfer that directly to the circuit board. Yay! See, it has my image just flipped back around. After 35 minutes, I can now remove the glass and the copper from the UV source, if I can get this out of here. And it's kind of warm, but it is definitely cemented down. So now, once I have this, I can then take it and cut off the copper. One of the annoyances about this glue is that it remains somewhat liquid for a while, and so you have to kind of dab off the extra excess. So I can do that right here. And this is just because it's just so much left over. So now I'm going to cut the extra copper off here. So I just simply go like this. You can basically use any pair of scissors. The 1-ounce copper leaf is just so thin that it doesn't really, nothing very much affects it. Or rather, it barely affects anything. Okay, so now we have a PCB, complete little PCB, made out of glass, and it's ready to have the toner transferred and be etched. When I transfer the toner, it's usually best, at least I've found, to place it in a paper, sort of paper leaflet thing. That's to help protect it from any kind of initial thermal shock and to help distribute the weight. I can then, either I can use foil to laminate this design first, or in my case, since I used extra heavy ink, I can just simply lay it straight on. Be sure that you do not have any of the toner over top of an area that is not covered in copper. Once this is nicely packed away in this little sleeve, you can peek to make sure everything's fine. I then can place this into a laminator here, and it goes through, heats up the ink, gets it very hot, and then melts it to the copper. And once it's melted to the copper, it's now connected to the paper and the copper. And at a later time, I can come back and wash off the copper. Now, I'm only doing this once on video, but what I generally do is I'll run it through here 4 times, each time flipping it upside down. Okay, this is a total of, I think, the 8th time through the machine. It is now off. I can peek underneath and I can see, yep, there is my glass, and on the back is nicely affixed the transfer stuff. So let's see if I can record this while I do it. But the idea here is you want to be very careful not to apply too much pressure in one location lest you break the glass. So I very kind of firmly press, get it all up to the right temperature, and then I kind of knead over it so it doesn't really get damaged. Just very carefully pressing on it. And I'm not applying too much pressure in any one point, but I'm still applying enough to get the toner transfer paper to really stick to that copper. Once this is done, I can then take this up. I'm going to take it over to the sink here. Put it down just for a second though. I can draw warm water, and I don't really want to get it directly in the stream, otherwise it'll knock the paper off. But what I want to do is I kind of want to lay it down next to it, so it's just in the stream, and it'll just sit there nice and smooth for about 5 minutes. Toward the end of the process, you can hurry it along just by allowing the water to trickle over it, and the paper will come off, and then you will be left with your absolutely gorgeous board. Now, this is not quite done yet. I need to etch off all of the copper, but the plastic here is protecting the copper from the etchant. The etchant is right over here, and for me, I'm using ferric chloride. It's the stuff on the right. The copper chloride, the U stuff, is on the left. I go through this stuff pretty quick because I really don't like to boil it or anything else. I just have it sitting out at room temperature, and as you'll see in a moment, I suspend the boards upside down so that you don't have to worry about vertical immersion or anything else, and it turns out there's a sort of convective flow that goes on in order to help make it go quicker. So for this part of the process, I'm going to be taking the copper off the board here, and I'm going to be doing that with the ferric chloride here. And I simply lay this in the ferric chloride. I do it kind of, I guess, diagonally in order to prevent any kind of bubbles, and I also do it very carefully in order to prevent it from falling underneath. By keeping it on top, I can keep the convective forces moving, and everything is fine. Okay, so now that the last of the copper has come off in all the areas that I don't want copper, you can now see the finished board here. Still has some ferric chloride on it, but you can see that for the most part it's clear. So what I'm going to do is I'm going to run this under cold water, and this washes off the ferric chloride. And I'm going to leave that running there for a moment. I'm going to come back with a little bit of steel wool here. And you want to be very careful with steel wool not to wipe off any of the UV ink, but instead you want to be very careful just to wipe off all of the extra toner stuff. So it kind of goes slow, and you kind of go over every little thing, and you got to look at it manually, make sure that you didn't miss anything. Also, be careful not to touch the copper at this point in the process, because it's very difficult to get the tarnish off once you've encased it in the polyurethane. So feel free to touch the glass as much as you want, don't touch the copper. The other thing to note is at this point in the process we can no longer use any alcohol or acetone or anything else, because the UV glue is very susceptible to corrosion from just about anything. Almost done here. Just wiping off the last little bits of the toner transfer stuff. Actually, it's straight up toner at this point. And so what you'll notice is that there are black spots still while you're wiping the stuff off. And these black spots will slowly go away as you continue on wiping. And if you look at it after a little bit, there will be basically no black spots left. You want to do that under running water too, so that it immediately takes all of the toner off. Once done, just damp it down with a paper towel. Again, try to avoid touching the copper at this point. For this part of the process, I'm going to be using some Kester pet solder paste. This is specifically the no clean kind. You have to use the no clean kind because the kind that you need to clean off usually requires alcohol. And if you use alcohol and you use this, what do you call it, the UV ink stuff, then the UV ink stuff will degrade very quickly. So you want to avoid anything that requires alcohol on this part of the process or later. So what I'm going to do is very carefully take some of this, and I just start dabbing it onto all the little pads here. And I'm going to be done with this soon. So once I've dabbed down all of the dots, as you can see here, they're all kind of coated in this nice, what do you call it, the solder paste. Then you can start laying down the parts. One at a time. Although since I'm actually moving along here, I guess I'll just stay recording for the rest of it. Once you put them down, you want to just kind of push on them just a little tiny bit in order to give them the extra little bit of sticking power. That is for the next part of the process. Okay, and last but not least, I need a little connector. was actually the biggest part of the whole process. Okay, so now I have all of my parts in place. Okay, for this next part of the process I'm going to be using this nice little, what is it, I guess 600, 500 watt heat gun here. It's from the 1970s, but works pretty good. So I'm going to turn it on, and if you stuck down your parts effectively, they will not be flying anywhere. So you kind of want to heat up the whole board somewhat evenly when you're doing this. Just kind of heat all around so that you don't crack the glass. I believe this stuff is tempered, and I have yet to crack it doing this, but that doesn't mean I'm not crazy nervous about it. You'll notice that kind of early on the paste begins to look a little bit more tacky. And at this point I'm just going to start blasting it. You can watch it as it liquefies it immediately. Okay, and it is done. While it's still hot, what I'm going to do is I'm going to use a little bit of solder to tack down a couple of places I'm not quite satisfied with. You want to do this while it's still hot so you don't crack the glass. I've already cracked the glass once by doing this on a cold board. Oh no! There we go. Okay, so we're almost done here. We have our board, but you'll notice that it's not really clear. It's kind of translucent, with even a couple areas that when I was taking off the toner transfer stuff, that it actually cut through and damaged the UV glue. So, first of all, let's at least test this. I'm going to lay that in there, and I have my little tiny ISP programmer, well, kind of a redesign of much smaller, micro tiny ISP programmer I made. And I just plug it in. If I can get it in there. There we go. Can I go over here, I have my little AVR code, all the C over there on that side, and all I have to do is just type in make, and hit program. And so now I should be able to pick this up, and if it worked, I should be able to touch it, yep. So I can get a whole array of colors depending on where I'm touching. And I'm actually touching the glass side, so you can see that the electronics are here on the top side, but the touch sensitivity stuff works all the way through the glass. That means you can have your electronics on the back side, and you have touch sensitive electronics on the back side, and you can touch on the front, which I think is pretty neat. I think I'm going to do something with it. Again though, we still have that problem of the sort of translucency. So the last part of this is to put on some polyurethane, and that's pretty straightforward. So my preference is this fast drying polyurethane superior durability finish. My only complaint with it is that it doesn't really end up very clear, so I'm sure you guys, if you look around, would be able to find something to make it even clearer, and that would probably be for the best. So I take a little paintbrush and I literally just start drawing it on, just painting it on. And so already, you can see if I hold it up, there is a big difference. If I can get this thing to focus. Focus. There's a big difference between the side with the polyurethane and the side without. So I'm going to end up coating the rest of this in polyurethane. But before I do that, it's probably best if I just show you what it looks like when it's finally done. this is one that has been completely done. It is nice, and I can get it to focus. Nice and crystal clear. Come on, focus. Focus. Anyway, it turns out pretty crystal clear and works pretty well. So I hope you guys found this at least interesting, and you can feel free to read my blog post about it for more details. Thank you.